We all know the story of Newton, who was once sitting under an apple tree contemplating about the stars and the planets when suddenly an apple fell on his head. So Newton tossed the apple up and down a couple of times, and then he thought, what made the apple come down? It was then that he struck upon the idea of gravity. So what is gravity? When we toss a ball up, it comes down. This is because of the force of gravity. In the absence of the gravity of the Earth, the moon would have traveled in a straight line. However, the gravity of the Earth causes the moon to change its direction and then start moving along an elliptical orbit around the Earth. So based on these observations and certain other studies, Sir Isaac Newton finally proposed that every mass attracts every other mass in the universe with a force called gravity. So gravity, as we studied earlier, is a non-contact force. So what are the characteristics of this force? To understand that, let's consider two masses m1 and m2. Now, according to Newton, both these masses will attract each other with a force of gravity F. Now, this force F would be directly proportional to each of the masses and therefore would also be directly proportional to the product of the masses. If the two masses are separated by a distance d, then this force is inversely proportional to the square of the distance between the two masses. Remember, the distance is measured from the center of one mass to the center of another mass. Now, this relationship, F is inversely proportional to the square of the distance between the two masses, is also called the inverse square law. The inverse square law holds true for other non-contact forces as well, such as the force of magnetism and even the electrostatic force. So now we have two equations. F is proportional to m1, m2 and F is inversely proportional to d square. When we combine these two equations, we get an equation F is proportional to m1, m2 upon d square. Now, according to this equation, the force of gravitational attraction between any two bodies in the universe is directly proportional to the product of their masses and inversely proportional to the square of the distance between the two masses. And this statement is called Newton's law of universal gravitation. Now, in this equation, if we remove the proportionality sign, we get a constant g. And this constant is called the universal gravitational constant, and its value is 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. Now, what is the meaning of the universal gravitational constant and what is its definition? So from this equation, we get the value of g as f d square upon m1 m2. Now, if the masses are 1 kilogram each and they are separated by a distance of 1 meter, we would find that the value of g would be equal to the force of attraction between the two masses. And that force of attraction experimentally has been found to be 6.67 into 10 raised to minus 11 Newton. So, what is the universal gravitational constant? It is the amount of gravitational attraction between any two bodies whose masses are 1 kilogram each and are separated by a distance of 1 meter. Now you might wonder, if there is a force of gravity between any two masses, why don't these masses simply crash into each other? So here's the answer. if we have two apples whose masses are 1 kilogram each and are separated by a distance of 1 meter, then according to the law of universal gravitation, there is a force of attraction between the two apples. Now when we calculate this force of attraction, it comes out to be 6.67 into 10 raised to minus 11 Newton, which is almost equal to 0. It is so negligible that this force will not even overcome the force of friction that is there between the apple and the surface on which the apple rests. But these were two small masses. What about two large masses such as the Earth and the Moon, whose masses are 6 into 10 raised to 24 kg and 7 into 10 raised to 22 kg? The distance between the Earth and the Moon is 384,000 kilometers. Nonetheless, when we calculate the force of attraction between the Earth and the Moon, it comes out to be 2 into 10 raised to 20 Newton, which is very huge. Now this means that the force of gravitational attraction can act over very long distances, and it can act despite the fact that there is no medium between the two masses. And now, the summary of this video. Newton stated that two masses in the universe attract each other through the force of gravity. The force of gravity is directly proportional to the product of the two masses. And the force of gravity is inversely proportional to the square of the distance between the two masses, something that we call the inverse square law. Now, as we studied earlier, this force is always attractive in nature. There is no repulsion. And this force can act over very large distances. The force of gravity is independent of the medium between the two masses. So that's all in this video. In the next video, we will study a topic called acceleration due to gravity.